Welcome to the Scicom Machine Learning Tool tutorial. In this video, I will walk you through how to perform multiple regression using the gradient boosting regressor. We'll be working with the medical cost personal dataset, and I'll show you how the data is prepared, how the model is trained inside Scicom, and how we evaluate its performance. The dataset we're using is the medical cost dataset, which contains information about individuals and medical insurance charges they insured. The features include age, sex, BMI, number of children, smoking stats, and the region the person lives in. The charges column is the target we want to predict. Some of these features, like sex, smoker, and region, were originally stored as text. Before training the model, we converted these string columns into number values. This encoding step is important because most machine learning models, including gradient boosting, require numerical inputs. Here you can see a clear overview of the dataset's columns and preview of the encoded dataset that we'll be using for training and testing. Now let's take a moment to explain what the gradient boosting regressor is. Gradient boosting is an ensemble method, which means it builds a model by combining many smaller models. Instead of training one large decision tree, it builds many small trees, one at a time. Each tree focuses specifically on the errors made by previous trees, gradually improving the overall prediction. You can think of it as a series of small corrections that slows the shape model into a very accurate predictor. Because of this step-by-step improvement process, gradient boosting is excellent at capturing complex, nonlinear relationships, like those found in medical cost dataset. This slide shows the full workflow of our regression process in Scicom. We started with the medical dataset and split it into training and test sets, using 80% for training and 20% for test. During pre-processing, we also encoded anything string-based columns into integers. Next, the gradient boosting processor is trained on the prepared dataset. Once training is complete, we use the test set to generate predictions. Finally, we evaluate the model using the R-squared score, which measures how well the predictions match the actual medical charges. A higher R-squared value means the model explains more of the variability in the data. Now let's move on to our Scicom machine learning web app. I'll show you how to use this web app to make predictions with gradient boosting regression. First, let's name our project here, and then let's give a brief description of our project. Then let's select our data tab, which is the CSV file, tabular data type, and then let's click Upload CSV, and then let's click Attach File. After successfully uploading the medical bill CSV file, we can see the overview of our dataset on the Table tab. And if we click the Data tab, it will give us our summaries of this dataset. Now, let's move on to the pre-processing section. Let's choose our target column, which is the charge. Now let's choose our machine learning algorithm. Let's choose our gradient boosting regressor. Now let's choose our evaluation metric, which is the R-squared. Now let's click Perform. So we can see our R-squared value is 0.87, which is pretty good. And the parity plot shows our prediction overview. We can see the predicted values are very close to the 45-degree line, which means the prediction is very accurate. There are some outliers here, but most of the results are centered across the line. And here, it shows the predicted value and actual value. And if you click the data tab, we can also see the overall summary of our prediction. Thanks for watching.